Talking today about the greatest common factor. Greatest common factor shows factors that are shared by two or more numbers are called common factors. Okay, so we have our common factors. We did our prime factorization in our last video, and now we're talking about common factors in the greatest common factor, right? Also known as the GCF, right? The GCF. There are several different ways to find the GCF of two or more numbers. We have essentially the first method, right? So we have the first method, and the first method is to list the factors of each number and then find the greatest. This one right here, 8 and 8, that's the greatest. Or you can create a factor tree, okay? Just like we did last time, we can create a factor tree, okay? List all your factors out, right? With prime factorization, you have a 2, 2, 2, and a 7. 2 times 2 times 2 and 13. And, they share the 2's. This way is kind of a little confusing. You just list the factors. This way, I guess say this, it's a little confusing, but you will generally get the correct answer. This one here, you can leave out a factor, but it's probably the faster way to go if you make sure you don't leave out a factor. So let's dive in. Let me increase the width on this. All right, so gonna widen this out. Let's go right there, I think. Zoom in just a little more. There we go. All right, so we have show you just the different ways, right? You have 30. 30, that would be 1 and 30. That would be 2 and 15. 3 and 10. 4, get your calculator. 30 divided by 4. 7.5. No, and we know that this would be 5 and 6. 45. The factors of 45. All right. Well, all right. So the factors of 45, 1 and 45. Let's see. 2 and 2 is not going to work. 45 divided by 3 is 15. Is 15. And there we kind of already have found it. All right. 15 here. 15 there. So what is the greatest common factor? 15. So that's one way of doing it there, right? That's 15. The other way of doing it is that if you take and you do the factor tree, right? 30 and 45. All right, 30 and 45. You would say, again, this is 3 and 10. 2 and 5. This would be 9 and 5. 3 and 3. Greatest common factors are you have a 3 and a 3, a 5 and a 5. 3 times 5 is 15. Okay, so again, it's just all a matter of what way you want to go as you're doing this for your greatest common factor. It's all about what way you want to go. They both have their pros. They both have, again, their cons. And so we'll just do. First thing I'm going to do is right out of the gate, let's see if 54, let's see if 12 works out of 54. Nope. 54 does not divide evenly into 12. I don't know. I'm just going to try that right out of the gate and see if something like that works. But let's see. 12 and 54. If we do the prime factorization, right, it might be a little quicker. That's 2 and 3. This is 9 and 6. We know that's 2 and 3, and this is 3 and 3. So their common factor is 2 and 3 would be their common factor would be 2 and 3, which of course is 6. So 6 would be my answer here. Let's see here. 16, right? Let's again, 96 divided by 16. Hey, it works. All right, so 96 divided by 16 is 6. So that means 16 is my answer. That's kind of cool when that works. All right, 98 divided by 42. Nope, that doesn't work. So let's prime factor. Let's prime factor these out, right? We'll say 42 is 6 and 7. That is 2 and 3. 98. Let's see, 98 goes into 98. I'm trying to find a number that goes into 98. 2. Let's try 2. All right, so I'm going to have to do, oh, that's right, because it's a weird one, right? So this is 2 and 49, which means this is 7 and 7. So prime factoring, what does it share? It shares a 2 and it shares a 7. 2 and a 7, that is 2 times 7, which is 14. So my answer is 14. Okay, so we kind of get the gist of what we're looking for. Okay, we kind of get the gist of what we're looking for. There's 5, 6, and 7. All right, there's 5, 6, and 7. I'm going to let you do those. All right, I will let you do those on your own. 5, 6, and 7, and 8. Let you work those or whatever on your own. You can check your own answers. Make sure you do your own work. But you should end up with what I have here. Okay, again, for whatever fact or reasoning that you're doing this, you have to do your own work, show your own work. But there, I'm just skipping these because, again, gave great instructions for 1, 2, 3, and 4. You just do the same thing for 5, 6, 7, and 8, and that is what you should end up with. Also, 9. 9 is going to be 12. So if it's a 3-digit number, you just do this 3 times, right? 60 is 6 and 10. That's 2, 3, 2, 5. 120 is 60 and 2, which again would be 2, 3, and 2, 5, because we can just clone it from over here. And 210 is going to be 3 and 70, which is going to be 7 and 10, which is going to be 2 and 5. All right, so let's see what matches up, okay? Let's see what all matches up. Well, we know with these, let's see, we have a 2, we have a 2, and we have a 2. We have a 3, we have a 3, and we have a 3. We do not have a 7. This has a 5. This has a 5. This has a 5. There you go. So this would be, for number 10, this would be 2 times 3 times 5, which is 30. So that would be 30. All right, that would be 30. So let's go here, right? 44. 44 would be, let's go here. 44 would be 4 and 11, which is 2 and 2. 64 would be 8 and 8, which is 2 and 4, 2 and 4. That's another 2 and 2. That's another 2 and 2. 100, that is 10, 10. So that is 2, 5, 2, 5. And my greatest common factor there is the 2's, right? The greatest common factor there is the 2's. I have a 2, 2, 2, 2, 2, and 2. 2 times 2 is 4. 2 times 2 is 4. All right. And so we get how to do number 12, right? Number 12 works the same way. Actually, it doesn't, right? Let's factor this old school style. Let's go 15, right? That's going to be 1 and 15, 3 and 5. 28 is going to be 1 and 28, 2 and 14, 2 and 14, and 4 and 7. 70 is going to be 1 and 70, 2 and 35, 3, 4, nope, 5, and 5 and 14, 5 and 14, 7 and 10. All right, what's my common factor? Let's see. Common factor would be 1, 1, 1, 2, 2, no 2, 3, no 3, 4, no 4, 7, 7, no 7, 14, 14, no 14. So the answer to this one is just number 1, or number 12. Okay. Write a set of numbers whose greatest common factor is 20. That's kind of easy. 20 and 40, right? Greatest common factor would be 20. Write 3 sets. Well, that's just multiples of 25, right? So 25, 50, 75. Real easy. The florist is making identical bouquets using white roses, 60 red roses, 45 pink roses. What is the greatest number of bouquets the florist can make? So first, what is, all right, each color, what's the each color? That would be one where I'm going to do this because you're going to use both sides of the factor. So I'm going to say 1 and 90, 2 and 45, 3 and 30, 90 divided by 4, nope, 90 divided by 5 is 18. So 5 and 18, 90 divided by 6 is 15. 6 is 15. 9 and 10. All right, so 60, 1 and 60, 2 and 30, 3 and 20, 5 and 12, 6 and 10, 7 doesn't work, 8 doesn't work, 1 and 45, 3 and 15, 4 and then 5 and 9. All right, so you're going to use both sides of these numbers, right? The greatest common factor is I missed 15 over here. Where was 15? 15. Oh, 4 and 15. Missed 15. The greatest common factor is 15, right? So how many bouquets? There's 15 bouquets, right? There'd be 15 bouquets. How many of each roses? Well, that is the other, right? That's the other. That would be this number here. So there is 6 white roses. So 6 white. There is 4 red, and 3 pink. All right, last one. 2 pieces of fabric. One piece is 6 feet wide. The other piece is 7.5 feet wide. You have to cut those strips into equal strips as wide as possible. How wide would you have to cut the fabric? Okay, so this is one of those things where you got to turn feet into inches, right? You got to cut your feet into inches so that way you can get them into common things. So 6 times 12. 6 times 12 is 72 inches. And 7.5 times 12 is 90 inches. 7.5 times 12 is 90 inches. Okay, so 90 inches. I'm going to factor these out. 9 and 8, 9 and 10. Let's see. 9 is the greatest common is a factor. So this is 2 and 4. This would be 2 and 5. So they share a 9 and a 2. So 9 times 2 is 18. So it would be 18 inches is what the strips of fabric would be. All right. So that is our review of the greatest common factor. All right, that is our review of the greatest common factor. All right. I look forward to seeing you again. Thanks.